Okay, friends, we have a question in the same playlist that ABC is a triangle which is right angled at C. Basically, we have three basic triangles that is equilateral triangle where three sides are same, equal, and that is a isosceles triangle, second one, which having two sides are equal, and the third is the right angle triangle, which is right angled at a certain point. In this case, we have certain point is C, C as the um, right angled in ABC, triangle ABC. So, what we have that a line through the midpoint of M of the hypotenuse AB and parallel to BC intersects AC at D. Show that these three conditions we have to prove here. So D is the midpoint of AC. For this, first we have to draw the basic diagram, basic figures, so that we can understand the question easily and what we have to find out here and what we have to show it here. So first of all, we start with the basic lines. That is that is a line which is okay. So this is second line. Sorry. This is the third line, which is hypotenuse. Okay. Now we have a basic triangle here. So we have to name it. That is A. Here we have A here and B. That will be this one and C. Sorry, we have to make it capital C. This one is C, which is at right angle. We have to make it here that this is the right angle. Okay, this is at right angle. Okay, so basically here ABC is a triangle that is at C, it is a right angle. Now, what we have that A line through the midpoint of M, midpoint M of the hypotenuse AB. That is the hypotenuse. This one is hypotenuse. Okay, this is the hypotenuse AB. Okay, here is a point where M is the midpoint of AB. So that we have to point it here that a point, or we have to take a midpoint here. So to achieve a midpoint at AB. Okay, now it is clear that M. Now we have to write here that M is the midpoint M is the midpoint at AB. Okay, and parallel to the BC, parallel to the BC intersect AC at D. Okay, so we have to write D here. So AC is intersecting at D, which is the midpoint or midpoint at AB at M. So that we are starting given. So we have given here what we have given, that M is the midpoint of AC, AB. Okay, then I'm sorry, AM equals to MB. Is it clear here? Okay. Then MD, MD is MD is parallel to MD is parallel to BC. Okay, here, here we have AM is equals to MB and MD is parallel to BC. This is given. Okay, then what we have to show first to prove, what we have to prove first, what we have to prove first, that is D is the midpoint of midpoint of AC. So now solution, or we have to say that proof, proof here. Now we have to prove here. So basically, MD is parallel to MD is parallel to BC. Here, this is given. Okay. Then D is the midpoint of midpoint of AC by converse 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 midpoint here by midpoint here. Okay. Okay. Uh, we have a question that what is the converse midpoint theorem? So, what is the converse midpoint theorem? What we have that basically when I have right here. I have to write here that midpoint, converse midpoint theorem is if line is drawn, if line is drawn from the midpoint of one side of a triangle, triangle parallel to the second side, parallel to the second side, it will it will bisects. Okay, sorry, it will bisects bisects the third side. Okay, what we have that if line drawn from the midpoint of the one side, that is AB has a midpoint of at M, and a line a line is drawn from one side. Okay, midpoint of the AB to the second side of AC of a triangle, and MD and BC both are parallel to each other and bisects the third side. Okay, third side, that is A and C. Clear is it? So first will be proved here. First, first is proved here. First is proved here. Okay. Now the second one. Okay. Now the second one. Sorry. What is the second one? That is MD is perpendicular to MD is perpendicular to AC. Okay. This we have to prove here. So MD, that is here, here this one, MD is perpendicular to AC. What we have to prove here? That it is perpendicular to AC. So now we have to prove here. Sorry. Okay. Sorry for the inconvenience. And this is a technical glitch. Okay. So MD is perpendicular to AC. Now we have to prove that AC, that is the third side of the triangle, MD, that is perpendicular to BC, is perpendicular to AC. Okay. So as the DM parallel to DM parallel to BC, okay, as the DM parallel to BC and AC is a transversal. Okay, AC is the transversal. So angle MDC equals to, sorry, MDC, that is plus angle BCD, that is equals to 180 degree. Okay, that is 180 degree. So basically, this angle MDC and BCD D, this angle of a parallelogram. Okay. Corresponding sides of the parallelogram is 180 degree. Okay. We have to write here that corresponding side of the parallelogram will be 180 will be 180 degree. Okay. Now, uh, now we have to put it here so that we can write easily. Now, angle MDC equals to 180 degree, 180 degree minus 90 degree as angle BCD equals to 90 degree. Here it is clear. Okay. So angle MBC equals to 90 degree. That is clear here. Okay. Hence MD is perpendicular to AC. Clear that? Okay. Now starts with third one. That is CM equals to MA equals to half of AB. That is CM and AM. So first of all, we have to make a line drawn from this particular point to this particular point. Okay, so that this point, this one will be joining. After joining, okay, first we have to write here that now we have third one here. So join CM. So join CM. Now we have triangle. Now we have triangle AMD and triangle CDM. Okay, both we have a triangle that is AMD and CMD. Okay, clear here? Okay, so we have to put over here so that we can clearly understand what we have to write here. Now, triangle AMD and triangle CMD. Okay, AD equals to DC, that is D is the midpoint of AC, that is clear here. So angle ADM equals to angle CDN, that is equals to 90 degree. Earlier we have proved that. And MD equals to DM, that is common here. Common. Oh, sorry, writing mistakes. So common here. Now, ha, now by S SAS congruency, by SAS congruency, triangle AMD congruent to triangle CMT congruent to triangle CMT. Okay. Then then we have AM equals to CM, AM equals to CM by CPCT, by CPCT. Okay. So from this way, we have AM equals to CM equals to half of AV. This is clear. Since M is the midpoint of midpoint of AB. So here it is proved. Okay. Now this is the basic question here. Hence we have proved here.